For these problems, make sure you have the right base and the right key points. And so with the log with no base, the base is 10. So that's 1/10, -1, 1, 0, and 10, 1. And keep in mind that those numbers, if you need to write down the exponential base points first or reverse them, please do. So then you graph those points and you start by doing the A. The A is 1, -1. So you'd multiply all the outputs by -1 and then graph them as red dots or whatever color you wanted. The H is 3, so you'd move everything forward 3. But notice that I had to go by 2's. So when I graphed 1/10, -1, I graphed it in the middle because it's by 2's. When I graph 1, 0, it's in the middle. So keep that in mind. When I graph 10, 1, it's in the middle. Then I graphed 1/10, +1 because of the -1 on the A. And now I'm shifting everything forward 3, and it's in the middle because I had to go by 2's because it's base 10. All right, so then you get your graph once you move all the reflected points forward 3 with the asymptote. So how did I get the x-intercept? Well, you can see it's 4, 0, but you actually get it by solving. So you set it equal to 0. Remember, to find x-intercept, you set the problem equal to 0, and you solve from 6.2. So you would divide by -1. You would base 10, canceling the logarithm. 10 to the 0 is 1, and then you add 3 and you get 4. Important to do the algebra and not just look at the graph, because what if it's weird, right? So practice when it's easy, so when it's hard, it's not as bad. So the y-intercept does not exist. You can see that clearly when I try to put a 0 in here. Log of -3, that doesn't exist. The asymptote's at x equals 3, it is h. This is a logarithmic decay. The domain is 3 to infinity. The range is -infinity to infinity. Very slowly. There is no asymptote here, right? Only vertically for logarithms. The end behavior as x goes to 3, the graph is going up to infinity. And as x goes to infinity, it very slowly goes to -infinity. Well, what happens if you have something like a b in there, right? So if you have a b, you don't change anything. You're going to do these base points, 1/5, -1, right? 1, 0, 5, 1. Write the exponentials down if you have to. But that b has to be factored out. You have to remove that and divide everything by it. So the 1/5 divided by 3 becomes a 15th. The 1 becomes a third, and the 5 becomes 5/3. Then I graph those points. Okay, they're the ones that are in red. You can actually skip the orange points if you just want to go right to the modified points based there on A or B. Just go right to the red points if that makes you feel better and is easier. Then you're going to make sure that you look at H. This is never H if there is a B. Can't be. You have to take B out to get H. H is -2. Move the asymptote back to -2, and then move all the points back to, back to, back to. The x-intercept is found by setting it equal to 0. I mean, look at this thing. Where is that? Who knows? So set the problem equal to 0. Base 5 it. 5 to the 0 is 1. This drops down. You subtract 6 and get -5. Divide by 3. Evidently, that thing's at -5/3. How would you know that? By looking at the graph, right? So make sure you know how to do the algebra. To find the y-intercept, we put a 0 here, and we just get crazy log base 5 of 6, right? That's whatever this number is here. Evidently, that's log base 5 of 6. The asymptote is at x equals -2. This is very slow logarithmic growth. Domain is -2 to infinity. Range is -infinity to infinity. The end behavior is at -2. We go to -infinity. At infinity, we're going to infinity, though. So infinity, we're very slowly going to infinity. All right, let's do an ln problem, and then we'll look at the back. So an ln problem, what you do is you know it's base e, right? So you know this little base e here. So we have 1 over e -1, 1, 0, and e1. We still do the same thing. That negative right there is an a value. A is a multiplier of outputs. So I come to my outputs, I multiply them by -1. And again, if you just want to graph that point first, I do both. So I did the normal ones, and then I did, this would reflect across the x-axis and be +1. The 1, 0, though, won't change with an a value. And then the e1 got reflected in the -1. You can just start with the red ones, though. I'll say that again. The h is -2, so you go back 2 and you drag all the red points back 2, and then you start the process. You can clearly see that the intercept's -1, but why? Well, if I set it equal to 0 and I divide by -1, I get 0. If I base e it, the ln cancels. E to the 0 is 1. And if I subtract 2, I get -1, confirming the graph has the right x-intercept. The y-intercept is weird because it's an ln. If I put a 0 there, I get -ln of 2. the asymptote is x equals -2. This is slow logarithmic decay. Domain is -2 to infinity. Range is -infinity to infinity, making the end behavior -2 goes to infinity and 3 goes to -infinity. On the back, when you look at graphs, you got to be careful. I'm just going to tell you, some of you, if you downloaded it early, I actually have the wrong base on these two problems. Number 12, make sure that it's 2. And number 13, make sure that it's 3. I had those reversed in one of the versions. Make sure they're correct. So let's do one of these, and then I'll do one of the ones that had the wrong base. Okay, let's pick this one. This one's a log base 10 problem. It's weird. It's way over here. How do we do it? We start by looking at the asymptote. Okay? The asymptote says that h is positive 2, which means it'll be -2 when I put in the equation. Remember, opposite h in the equation. And then you move to the intercept. The intercept is supposed to be at 1. And I've already said I moved it forward 2. So let's go forward 2, right? And then where do I see a crosshair? There. So in these problems, you do h first and then you do k. In exponentials, it's the reverse. It has to do with the asymptote. The asymptote is h here. So when I come to write the equation down, I just got to remember, right, that it's log base 10. Don't write the 10. -2, okay, and then +1. Done. So down here, these problems, again, forgive me, number 13 is supposed to have a 3, and number 12 is supposed to have a 2. That only really matters if you check it on Desmos, but I had those two switched somehow. So we start with the asymptote. The asymptote is h equals 1. And so then we go to our intercept and we say, okay, we already moved it forward 1. How far did we move it up? We moved it up 2. K is 2. And if you have the right base, that'll make sense. So this one will be f of x is equal to log base 2, x minus 1 plus 2. Now, if you see a reflected one, okay, like this one right here, you just got to remember that when it reflects, that a is negative, right? So this look is a is -1. The intercept doesn't actually change. The intercept is still here, right? I don't have an asymptote. My h is 0, so all I have to do is realize it went up 1, so k is 1. So it's just kind of trying to logically, look at those graphs and figure out what I did to them. But start logically with, well, you should always start with your reflection first because your reflection comes before your asymptote, right? And if you don't have an h, why don't you put that in a parentheses? That way your k is clearly outside of the parentheses. Now for these SOL questions, this is one of the weirdest questions ever, but what they're really asking you, that c is what we call h. My apologies, is what we call k, because it's outside the parentheses, just like I was talking about here. So the question is, which one of these has a logarithm in which k is greater than 0, meaning k is positive? You have a positive k value. So k, remember, is going to move the graph up or down. So which of these graphs has been moved up is what that's asking. And then this question over here is asking about the end behavior of this logarithm. So you may use Desmos if you need to, but you don't actually have to. Let me explain why. Like if you think about this problem, it really has to do with reflections. This graph is nuts, but it hasn't been reflected, so it looks like this, right? And then it has an asymptote that moved it up 5, so it got moved up 5, right? But it still looks like this. So what is it as it approaches 0? It's going to -infinity. And you can confirm that on Desmos, but you didn't even need it. As long as you realize it didn't have a reflection, you're pretty much good. All right, work hard. We'll have a review day next class.